Hello, my name is Caitlin Green, and this is my vlog for the Chapter 9.1, textbook problems. As you can see here, I have a blank copy of the document, but what I'll be reading my answers from, as well as explain my thought process from, will be the sheet that I printed off to do my work on. So let's go ahead and get started. Number 1 says, in a human experiment, a researcher predicts that the subjects in the E condition will be more variable in the number of errors committed than those in the C condition. 22 subjects are randomly and equally assigned to the two conditions. Assume from prior research that the error are approximately normally distributed in the task. Test the researcher's hypothesis at alpha equals 0.05. So we know that K equals 2, and we know that N is going to be 11 because there's 22 subjects, so there's approximately 11 in each. And in this one, we are going to be, since they are equal, we'll be doing a F-max equation. So to go ahead and kind of set up our 7-step hypothesis, we will have a null value of sigma E squared is equal to sigma C squared. And the reason we're doing this is because there really is not a direction in this equation. It just says to test his hypothesis. So our alternative hypothesis is going to be sigma. How weird. Sorry about that. We will have sigma E squared is equal to sigma squared C, or it's not equal to sigma squared C for the alternative hypothesis. We know that alpha equals 0.05, so now we have to go and find the X max value so we can use it for our our F calculated variable. So to find F max, we have the S squared of the largest value divided by the S squared of the smallest. And so we found for these values that the sigma for E was 3.239, and the for C it was 1.286. So to find F squared, all we do is take and square that value. So for E we got 10.49, and for C we got 1.65. So we will take 10.49 and divide that by 1.65 to get a calculated value of 6.358 calculated. And now we have to find the F-max critical. So we're going to go to table E. We know that our alpha value is 0.05 and our K is 2. And our degrees of freedom is N-1, so it's going to be 10. So from that we find that our F-max critical value is going to be 3.72. So with our decision, we know that 6.36 is greater than 3.72, so we will reject HO and we will accept H1. And so in English, this just means that the researcher's hypothesis is correct and that the variability in the group, in the E group, was significantly greater than the number of errors in the C group. So this is just a brief look at what my work looks like for that problem. This one's a bit more organized than Chapter 8 was, just because it's going to be a little bit less information needed for each question. And now we're going to move on to number 2. It says an article in a journal reports the following statistics for 2 independent batches. It gives us the X bar, the sigma, and the number for both the E group and the C group. And as we can go ahead and see here, the N groups are not equal, and so we're going to have to do a little bit of a different approach than we did for number 1. So it says assume normality and compare the variances of the two batches, and it says use alpha 0.05 in a two-tailed test. So in this problem, We know that K equals 2. However, we also know that F is equal to the S squared of the largest divided by the S squared of the smallest, but because the ends are not equal, like I mentioned previously, we're going to have to go to table F instead of table E. And we also have to do a little something different with our alpha. We'll have to take the stated alpha and divide it by 2 when we get to that part. So now moving forward, we'll set up our we'll set up our 7-step hypothesis process. So we know that the null hypothesis is going to be the same as kind of before, as sigma squared of the E group is equal to sigma squared C or of the control group. So that means that our alternative hypothesis is going to be sigma squared E is not equal to sigma squared C. And we know that our alpha is 0.05. And now we have to go and find our F value. And the way we do that is, like I said before, we'll take the we'll take the squared values of our sigma or our S value, and so it'll be 4.2 squared divided by 1.8 squared, and we'll get 17.64 divided by 3.24 to get a F calculated value of 5.44. Now that we know that, we have to look to find the F critical. We know that an FCal 7, which is the degrees of freedom for the E group of 8 minus 1, is going to be in the numerator, and then 11, which is the degrees of freedom for C, is going to be in the denominator. And once we go to table F to find those values and such of where they meet up at the T, we will get a Z critical value of 3.76. So whenever we compare that to F calculated, we find out that F calculated of 5.44 is greater than 3.76. So in this decision, we will reject HO and we will accept H1. And that just means that the variance of group E was significantly greater than group C. And I'll briefly show you the way that my problem was set up. And obviously you'll be able to see more whenever you look at the photocopies I submit with this assignment. Now moving on to the last question, number 3. It says, using the results from problem 2, do a two-tailed test of the means, which is alpha of 0.05. And so what we'll do is set up our hypothesis, 7-step hypothesis question first, and so we'll have a null hypothesis of mu E is going to be equal to mu C, which means that our alternative, or our H1 hypothesis, is going to be mu E is not equal to mu C. We know that our alpha value is 0.05, and we have to do a little bit of work to find our T calculated, because we'll have to do the same setup as before when we're doing a T-test, and that will subtract the 2 x bars. However, we have to find the standard deviation of x bar 1 minus x bar 2. And whenever you put that in the equation, it looks like the square root of 17.64 divided by 8 plus 3.24 divided by 12. And we'll get a standard deviation of x bar 1 minus x bar 2 to be 1.57. And then we'll go put that in the equation to find T-cal. And we'll get 10.1 minus 12.2 divided by 1.57 to get a T-calculated value of a negative 1.34. And then to find T-critical, we are going to take the degrees of freedom, which is going to be 18. and we're going to use the alpha of 0.05 and take a two-tailed test to find that the t-critical value after going to table A is 2.10. And when we compare that to the absolute value of the t calculated, we find that t-cal is still in fact smaller than t-critical, and so 1.34 is less than 2.1. And so in this decision, we will fail to reject HO. And all this means in English is that the statistics from the two independent batches are not significantly different. So that was the results for the two-tailed test of the means. And as you can see here, this was my setup. And yeah, this has been my vlog for the chapter 9.1 textbook problems. We just went over questions 1 through 3. And overall, I felt like these were a little bit easier than chapter 8. I know that chapter 8 contributed a lot more, I guess, to understanding these problems in chapter 9, but I did struggle a bit more trying to understand the chapter 8 textbook problems than I did whenever I did these chapter 9 part 1 textbook problems. So definitely we'll need to just do a little bit of extra practice, but overall with this vlog I am feeling definitely more confident than I did whenever I made my last vlog on last Tuesday. So I really appreciate you watching and listening to me stumble and ramble on about statistics, and I hope you have a great night, and I'll see you tomorrow in class. Thanks.